In this video, I will talk about the process of making a measurement with a voltmeter. Now, this is the circuit that I have, and I want to make a measurement with the voltmeter. I want to measure a potential difference between 2 points. And let's say that I want to measure the potential difference between points A and B. The way that I will use the voltmeter to make a measurement is the following. Let's say this is my voltmeter, and here is the screen that's gonna tell me what is the number. Now let's say that I want to measure VB minus VA. Now the voltmeter will have two cables, and one of them is gonna be the black cable, the other one is gonna be the red cable. It is important that you have your voltmeter set up correctly. If since I want to do VB minus VA, the way that you will set your two cables is the following. The red cable needs to go to B, and the black cable will need to go to A. If you set your cables in this way, you will measure VB minus VA. If you do the opposite, if you place the black cable on point B and the red at A, then you're really measuring VA minus VB. You will just be off by a sign, essentially. So what I'm gonna do now, I'm gonna take the red cable of the voltmeter and I will place it at point B. Since my background is black, let's say, is there anything dark? Let's use this one. So I'm gonna pretend that this is the black. Okay, let's say this should be black, and let's do this for red. Okay, unfortunately I did not think about my background. All right, so that's how you will set up your voltmeter to make your measurement. Now it is important to understand, when I make a measurement in this circuit of a potential difference, I should not be disturbing the thing that I want to measure. Okay, this is my circuit. When I make a measurement of the potential difference, I should not be changing the circuit. If I am changing the circuit, then I'm not really making the measurement in the circuit that I want to do the measurement on. Okay, so when you make a measurement for whatever it is in the sciences, whenever you make a measurement, you should not be disturbing significantly your system. And in this case, the system is the circuit. Now, for this simple circuit where I have EMF and one resistor, I found, applying Kirchhoff's loop rule, that plus IR minus EMF equals 0. So the current in this circuit is EMF over R. Now here's the thing. When I place the voltmeter this way, and we call this, I'm connecting the voltmeter in parallel with the circuit, then really what I'm doing, I'm changing this circuit to this one. Okay, and if you want, I'm modeling the voltmeter R as a resistor with resistance R prime. Okay, so when you place the voltmeter this way to make your measurement in this circuit, you effectively change the circuit and you have this. Now, we have worked with Kirchhoff's rules, and we found that for this circuit, I get plus IR minus EMF equals 0, I equals CMF over R, and then the same thing for the other loop, I prime, R prime, minus EMF equals 0. Now, what is I? This is current I, and this is the one that is I prime. Now, of course, the current that I have going through the battery is now I plus I prime. So you can see, when you place the voltmeter to make a measurement, you're changing the circuit, and you are in fact changing the current that goes through the battery. It's not the same circuit anymore. You wanted to make a measurement here, but now in fact you have this circuit. And this circuit has a different current going through the battery. Now here is how I can essentially try to decrease the impact of the voltmeter in changing my circuit. Okay, so in this circuit you just have current I flowing all over. What I want is to change this circuit to be essentially as close as possible to this. What's the difference? I have EMF, that's the same. I have current I, that's the same. And then here you will see that I have I plus I prime. Now, what I want is I plus I prime to be as close as possible to I. How can I do that? The only way that I can say, okay, what if I have I plus I prime and I want this to be more or less equal to I, then the way that I can do that is only if I prime is much less than current I. Okay, if you have, let's say, 100 plus 0.1, then if I say 100.1 or simply 100, they are not off by a lot. Okay, so I need to minimize the current I prime in this circuit so that I can say that the sum of these two is roughly the same as just I. Now, so I need to make the current I prime to be very small. What this means, I need to make the current that goes through the voltmeter as small as possible. Now, how can I do that? So I see that the current I prime is equal to EMF over R prime. The current I is EMF over R. So let's see, I'm running out of space here. So what I need is for EMF over R prime to be much less than EMF over R. Now, I don't have control of the power supply, okay? The power supply is what it is. And I don't have control over the resistor R. That's my circuit. The power supply and the resistor R, that is my circuit. I cannot change those just to, if I should not be disturbing the circuit. So what I do have control over is R prime. That's the resistance of the voltmeter. For this condition to be true, I need to have a voltmeter that has a resistance much greater than R. Okay, and when we make voltmeters, we make them so that the resistance of the voltmeter is much greater than the circuits where we use them in. Okay, so this is the answer to the question, why do voltmeters have a very large resistance? That is because with a very large resistance here, you end up having a very small current flowing through them, and this results in not changing the system, the circuit that you wanted to do the measurements on. Now, this is one of the limitations of using a voltmeter, okay? So just because you get a number does not necessarily mean that that's the correct number. Imagine where you make a circuit where this resistance and the resistance of the voltmeter is the same. You have just, if that's the case, you have current I here, and here you will have a double current, a current that is twice as large as the current that you have in this circuit. So by making the measurement, you have changed your circuit. So it is important to be aware of this limitation of voltmeters. Just before you make any measurements, make sure that your voltmeter has a resistance that is large enough to not disturb the circuit where you want to do the measurement on.